Hello everyone, and on this video we will be going over how to solve quadratic equations by using the square root property. Okay, so before we get started, first thing we want to do is a quick reminder of how a quadratic equation will look. Quadratic equation is an equation written in the form ax squared plus bx plus c equals 0. Okay, so in other words, it's just where your highest exponent is basically a 2 for any of your variables. Okay, so now we're going to take a look at the square root property. Excuse me. Okay, so for the square root property, for any non-negative, well, I guess you could say not all. Okay, for any real number, or for any number c, we'll just have c represent any number at all. If x squared equals c, then x equals square root of c, or x equals negative square root of c. And a lot of times they will combine these two, and they will just make it x equals plus or minus square root of whatever that c value is. Okay, so let's do a quick example. Okay, so let's say, for example, we wanted to solve c squared equals 25. Okay, so c squared equals 25, just rewriting it. You notice here, whenever you have a squared value equal some numerical value, or a squared variable, or whatever it is, equal some numerical value, it's just x is equal to the positive and negative of the square root of that value. So really, if you square root both sides, you'll see you'll end up with square root of c squared equals plus or minus the square root of 25. Okay, now if you notice, when there's no index, it's automatically assumed to be a 2. And if you remember, when the exponent and index are the same, they cancel each other out. So basically this 2 would cancel out with the index of 2, that would be right there, which would just leave us with c. And that's equal to plus or minus square root of 25 is equal to 5. So c is equal to plus or minus 5. Or you may have it written as c is equal to positive 5, or c is equal to negative 5, which is basically the same as the plus or minus. Alright. Okay, so let's go ahead to our next example. Alright, so let's say, for example, you wanted to solve x squared minus 12 equals 0. Then you want to solve that one for x. Okay, so the first thing you'd want to do that we didn't have to do in the last one is you want to isolate your squared term. Or variable. Okay, now in this case we have a squared variable. So we want to isolate that. So you have x squared minus 12 equals 0. We just go ahead and add 12 to both sides. Where these two will cancel each other out. Alright, so that leaves us with x squared equals positive 12. Okay, now once we have our squared variable or term by itself, then we just go ahead and square root both sides. Okay, so if we square root both sides, we have the square root of x squared equals plus or minus the square root of 12. Remember, don't forget your plus or minus. Okay, so if you notice with your square root of 12, it's a little side note here. Remember, square root of 12 is equal to square root of 4 times 3. Remember, whenever you have that number factored, you can separate them. So you have square root of 4 times square root of 3. Square root of 4 is equal to 2, so that leaves us with 2 square root of 3. So square root of 12 is equal to 2 square root of 3. So since our exponent and our index will cancel each other out, that will leave us with just x equals plus or minus 2 square root of 3. Or, of course, we can write it as x equals 2 square root of 3, or x equals negative 2 square root of 3. Okay, so either one of those would work, depending on how the question is set up and how they want you to answer it. All right. Okay, let's go ahead to our next example. Okay, what if, for example, we wanted to solve 4x squared plus 25 equals 0. Alright, so just like before, your first step would be to isolate your variable, or your squared variable. Okay, so you're going to isolate your squared variable. So since we have 4x squared plus 25 equals 0, we're just going to subtract 25 from both sides, which would give us 4x squared equals negative 25. Okay, now in this case, we can go ahead and divide both sides by 4. If anything divided by itself is 1, so those two 4's cancel each other out. So we have x squared equals negative 25 over 4. Okay, so now that we've isolated our x variable, we just go ahead and square root both sides. Okay, so if we square root both sides, we have square root of x squared equals square root, oh, got my plus or minus. Plus or minus square root of negative 25 over 4. So, just like before, don't forget your plus or minus. Let that focus a little bit. Yeah, it looks a little bit better. Alright, so just before I do that, you see your square and square root cancel each other out, so you just have x equals plus or minus. Remember, you have a negative square root. Okay, so that's just like saying the square root of negative 1 times 25 over 4. So x equals plus or minus, you can separate those two. So you have square root of negative 1 times square root of 25 over 4. Okay, now we're going to kind of do both of those separate, because remember, we'll do a quick note here. Square root of negative 1 is equal to I. That's our complex number. Okay, and also if you remember, square root of 25 over 4 is equal to square root of 25 over square root 4. Okay, the square root of 25 is 5 and square root of 4 is 2. So this will simplify to be x equals plus or minus either I times 5 over 2, or you can just make it x equals plus or minus 5 over 2I. Or just like before, we can separate it. So x equals 5 over 2I, or x can equal negative 5 over 2I. Okay, so remember, not all solutions are real numbers. They can actually have complex solutions also. Okay, so if you're a little rusty on your complex numbers, you can go ahead and rewatch that video. Alright, so let's go to our next example. Alright, so what if we have, for example, we wanted to solve, say, 7z squared minus 10 equals negative 3. Alright, so just like before, your first step would be to isolate the squared variable. Okay, so once you isolate your squared variable, then you can go from there. So you have 7z squared, clean up that z a little bit. So 7z squared minus 10 equals negative 3. We just go ahead and add 10 to both sides. For that, just go ahead and cancel each other out. So we go to 7z squared equals negative 3 and positive 10 is positive 7. So now we go ahead and divide both sides by 7. Anything divided by itself is just 1. So we have z squared equals 1. Okay, now once we do that, we go ahead and we isolate, square root both sides. Okay, and again, you want to remember your plus or minus. Alright, so we go ahead and move that right on up a little bit. So if we square root both sides, square root of z squared equals plus or minus square root of 1. Again, our exponent and our index will cancel each other out. So you have z equals plus or minus, and remember square root of 1 is just 1. So you have z equals plus or minus 1, or you can write it as z equals 1 or z equals negative 1. Okay. Alright, so let's go ahead and do another example. Okay, so let's say, for example, if we want to solve 3q squared equals negative 3. Let me kind of clean up that 2 a little bit. There we go. Okay. So to solve this one, remember our first step is still to isolate your squared variable. So 3q squared equals negative 3. All we have to do is divide both sides by 3, where anything divided by itself is equal to 1. So you have q squared equals negative 3 divided by 3 is negative 1. Alright, so once again we have our q squared isolated. So we square root both sides. And after a while you'll just end up skipping this square root both sides part, because you know if you square root both sides you'll just end up with q equals plus or minus square root of negative 1. But I show it anyway just for the step-by-step. So square root of q squared equals plus or minus square root of negative 1. And remember your plus or minus. Alright, so once you do that, remember your index and your exponent cancel each other out. So you just have q equals plus or minus, and if you remember, your square root of negative 1 is equal to I. So it's plus or minus I. Or you can write it as q can equal positive I, or q can equal negative I. Okay, so either one of those answers will work. Alright, so let's go ahead and do another example. Okay, so what if we wanted to solve, let's say y squared over 4 plus 100 equals 201 over 2. Okay, so that one's a little more complicated than the previous one. Okay, but the steps are still the same. Your first step is to isolate the squared variable. Okay, so that means if we start off with y squared over 4 plus 100 equals 201 over 2, we just go ahead and subtract 100 from both sides. So that gives us y squared over 4. Kind of clean that up a little bit. So y squared over 4 is equal to 201 over 2 minus 100. Okay, so quick note, 100, you can make that equal to 200 over 2 just to get our denominators matching up. So y squared over 4 equals 201 over 2 minus 200 over 2. Okay, so if we go ahead and subtract our numerators, 201 minus 200 is 1/2. So y squared over 4 equals 1/2. Because remember, 201 over 2 minus 200 over 2, that just becomes 201 minus 200 over 2. 201 minus 200 is 1. So you have your 1/2. Okay, so now we just multiply both sides by the denominator to get our y squared by itself. So we go ahead and multiply both sides by 4. Okay, so these two will cancel each other out. So you have y squared equals 1/2 times 4, basically 4 divided by 2, which is 2. Okay, so now you can go ahead and square root both sides. And again, you want to remember your plus or minus. Okay, you don't want to forget that. Okay, so the square root of y squared equals plus or minus square root of 2. Alright, so once again, our square and square root cancels each other out. So you have y equals plus or minus square root of 2, since the square root of 2 can't be simplified any more than that. So you can write it like this, or you can write it as y equals square root of 2, or y equals negative square root of 2. Okay, and that, either one of those would be your final answer. Alright, so let's go ahead and do another example. Okay, so what if we wanted to solve 3d squared equals negative 15? Okay, so just like before, your first step, we need to isolate the squared variable. Okay, so our 3d squared equals negative 15. We're just going to divide both sides by 3. So that gives us d squared equals negative 15 divided by 3 is negative 5. Okay, and once we've isolated that, we just go ahead and square root both sides. And of course, you want to remember your plus or minus. So the square root of d squared is equal to plus or minus the square root of negative 5. Okay, remember the square and the square root cancels each other out. So you have d equals plus or minus the square root of negative 5. But you want to remember that the square root of negative 5, you can actually rewrite that as square root of 5 times I. Okay, so that gives us d equals plus or minus the square root of 5i. Yep, let me kind of close this up a little bit. Square root of 5i. Now it's really, really important to remember your I goes on the outside of the square root symbol. You don't put it up underneath the square root symbol like right next to the 5. Because here your square root of 5 is a number being multiplied to I. So that's a very, very important step to remember, because if you put square root of 5i and the I is underneath the square root symbol, you'll most likely get that problem wrong because those are two separate numbers. Okay, so square root of 5, I'll do a quick note. Square root of 5i is not the same as square root of 5i. Okay, so you want to be really, really careful with that. Okay, so, or you can write it as d equals square root of 5i, or d equals negative square root of 5i. Okay, and again, just making sure that the I is on the outside of the square root bracket, not underneath it, because I'd hate for you to do all this work and end up getting no points because of a little minor error like that. All right, so let's go ahead to our next example. So here we're going to switch up how the problem looks just a little bit. So let's say if we wanted to solve x minus 1 squared equals 16. Okay, so it's not just x squared. Now we have x minus 1 squared equals 16. Okay. So before, when we had just the variable squared, we would isolate the x squared or y squared or whatever it was. Here we have x minus 1 squared. So our first step is to make sure that our variable term is isolated. We don't have to isolate the x squared because it's not just x squared. We want to make sure that entire term is isolated. Okay, so first, x minus 1 squared term is already isolated. Okay. So since it's already isolated, we just go right ahead and square root both sides. So just square root both sides. Okay, so that gives us our x minus 1 squared equals 16. We're just going to square root both sides. And of course, remember your plus or minus. Okay, so just like before, our square and our square root cancel each other out. So that just leaves us with x minus 1 equals plus or minus. And since we know that square root of 16 is equal to 4, that leaves us with plus or minus 4. Okay, now we didn't want to solve for x minus 1, we want to actually solve for x. So we go ahead and just add 1 to both sides. Remember that plus or minus still stays there. Okay, so that gives us x is equal to, and what we're going to do is we're going to put this value first. That plus 1 goes first. So we have 1 plus or minus 4. Okay, now in this case, we won't leave this as our answer because this can be simplified more. Okay, because remember, when you have that plus or minus, that just means that x is equal to 1 plus 4, or x is equal to 1 minus 4. Okay, so we go ahead and just solve both of those, then we'll have our two answers. So if x is equal to 1 plus 4, that just means that x can be equal to 5. Or if x is equal to 1 minus 4, that just means that x can be equal to negative 3. Okay, and if you plug both of those in, you'll see that both of them will give you the correct answer. Okay, so if you plug in 5, 5 minus 1 is 4, 4 squared would equal 16. You plug in negative 3 minus 1 is negative 4, negative 4 squared will give you 16. All right. Okay, so let's go ahead to our next example. Oops, straighten up my papers a little. There we go. All right, so let's say, for example, we wanted to solve 3x plus 8, 3x plus 8 squared minus 6 equals 0. All right, so just like before, your first step is to isolate your squared term. Isolate squared term. So our 3x plus 8 squared minus 6 equals 0. We're going to go ahead and add 6 to both sides, where those two would cancel out. So that will give us 3x plus 8 squared equals positive 6. Okay, now once our squared term is isolated, we go ahead and square root both sides. And remember your plus or minus. Straighten that up a little bit. There we go. Okay, so if we go ahead and square root both sides, so we have the square root of 3x plus 8 squared equals plus or minus square root of 6. So once again, our square and square root cancel each other out. So you have 3x plus 8 equals plus or minus square root of 6. Okay, so now we can go ahead and solve for our x value. So we just go ahead and subtract 8 from both sides. So that would give us 3x equals, just like before, the previous example, we put the value that we just moved over in front. So this would be negative 8 plus or minus square root of 6. Okay, now to solve for our x, we just divide every term by the coefficient 3. Okay, so anything divided by itself is just 1. So that gives us x equals negative 8 over 3 plus or minus square root of 6 over 3. Okay, so really we can go ahead and separate those two. So this is an answer, but you may have some that will want it broken up. So x can equal negative 8 over 3 plus square root of 6 over 3. Or x can equal negative 8 over 3 minus square root of 6 over 3. All right. So let's go ahead to our next example. Okay, so what if we wanted to solve 2m minus 1 squared minus 4 equals 14? Alright, so what I want you to do is I want you to press pause and try solving this one on your own. Alright, so I'm assuming you have already pressed pause and you have worked this one out on your own. So now we're just going to verify your answer. Okay, just like before, your first step is to isolate your squared term. So our 2m minus 1 squared minus 4 equals 14. We're just going to add 4 to both sides, where these two would cancel each other out. So that leaves us with 2m minus 1 squared equals 18. Okay. So once we've isolated our squared term, we just square root both sides, where of course we have to remember our plus or minus. Okay, so if we square root both sides, that's the square root of 2m minus 1 squared equals plus or minus the square root of 18. Alright, so remember the square and the square root cancel each other out. So that just leaves us with, oh, we don't need the parentheses there, 2m minus 1 equals plus or minus, okay, now note that square root of 18 is equal to square root of 9 times 2. Okay, since that's factored out, we can go ahead and just separate those two. So you have square root of 9 times square root of 2. Okay, square root of 9 is equal to 3, so that leaves us with 3 square root of 2. So square root of 18 is equal to 3 square root of 2. So that leaves us with plus or minus 3 square root of 2. Okay, so just like before, now that we have our squared simplified, we can go ahead and solve for our variable. So we just add 1 to both sides, where these two would cancel out. So that leaves us with 2m equals, again, we put our numerical value that we moved over first, so 1 plus or minus 3 square root of 2. Okay, now we just have our 2m, so we go ahead and divide all the terms by our coefficient of 2. Okay, so anything divided by itself is just 1. So we have m is equal to 1/2 plus or minus 3 square root of 2 over 2. Or to write it as two separate solutions, you have m is equal to 1/2 plus 3 square root of 2 over 2, or m is equal to 1/2 minus 3 square root of 2 over 2. Alright, so we're just kind of separating those two answers again. Okay, hopefully this matches up with the answer that you received. Alright, so let's do one more example. What if we wanted to solve 4n plus 6 squared minus 8 equals 56? Alright, so what I want you to do once again is go ahead and press pause and see if you can work this one out for yourself. Okay, so assuming you've pressed pause and you have worked this one out, let's go ahead and verify your answers. Okay, so just like before, first thing you want to do is isolate your squared term. Okay, you have 4n plus 6 squared minus 8 equals 56. You just go ahead and add 8 to both sides, where these two cancel out. So that gives us 4n plus 6 squared equals 64. But now that we have that isolated, we square root both sides. And of course, we remember our plus or minus. Alright, so once we square root both sides, you have 4n plus 6 squared equals plus or minus the square root of 64. And of course, square root of 64 is equal to 8. So once our square and square root, straighten that out a little, cancel each other out, we have 4n plus 6 equals plus or minus 8. Okay, so now that we have our square canceled out and it's nice and simplified, we can go ahead and solve for our n. So we go ahead and subtract 6 from both sides where those two cancel out. So that leaves us with 4n equals, again, we move our value that we moved over, we put that first. So negative 6 plus or minus 8. Okay, so to solve for n, we just divide every term by our coefficient of 4, where anything divided by itself equals 1. So that leaves us with n is equal to negative 6 over 4 plus or minus 8 over 4. Make that a little bit bigger. Negative 6 over 4. There we go. Okay, now for this one, we can't leave it like this because it can't be simplified. So that means n can equal negative 6 over 4 plus 8 over 4, or n can equal negative 6 over 4 minus 8 over 4. Okay, so now we're just going into adding and subtracting our fractions. So I'll go ahead and separate our little line there. So negative 6 plus 8 is positive 2. So remember, this just gives us negative 6 plus 8 over 4. Or n is equal to 2 over 4, which simplifies to n is equal to 1/2. Okay, now with this one, same thing. This simplifies to n is equal to negative 6 minus 8 over 4. Or n is equal to negative 14 over 4. Or that can simplify to n equals negative 7 over 2. Alright, so hopefully this video made sense, and I will see you on the next video.